Hello guys, welcome back to Maison African Motives, still on A-level mathematics, working on logarithmic and exponential functions. So in this platform, we shall be focusing on the laws of logarithms and the application that we are going to have on our laws. We managed to work on exponential equations, which is another part of the logarithmic and exponential functions. So we shall have another part again, working with the functions itself, that is to draw a normal function and their inverse is that part we shall talk about it later on in another class. So for now, we just need to understand the laws of logarithms. Okay, so under the laws of logarithms, we have got here the normal log and the Napierian logarithm, which is given as ln. So meaning to say, the normal laws that we are used to, that is the logarithm of a, let's just say we've got the logarithm of a plus the logarithm of b, where we are adding logarithms. We know that we are going to multiply the numbers under that same logarithm. So this is the same consideration under a ln. So this can be given as the ln of a, take note here, plus the ln of b, which is equivalent to the ln of a times b. So we can just have ln AB in this case, like this. All right. So if you are adding logarithms, you're going to multiply the numbers under the same log. A ln is just a log, just that if you are given, let's say, ln of x, all right, let's have it as ln of x. It simply means the logarithm of x in base of e. So that is a ln, the ln part in this case. All right, so let me just indicate this ln part. It's log base e. This ln part, it simply means log base e. So if that is the same, because we are adding logarithms and the base is the same. So you're simply saying this is log base e, this is log base e, this is log base e. So it gives us ln a, ln, and so on. So that is how we are going to have this. Remember, if the bases are the same, we can multiply these numbers. The same approach is on our subtraction. If you are subtracting, we are going to apply the same thing. Sorry, here we are supposed to have the log on this side. The log of a minus the log of b is equivalent to the log of a over b. That is the same thing that you're going to have under our Napierian logarithms. That is the ln of a minus the ln of b is the same as the ln of a over b, like this. All right, so the same thing if you are multiplying. Let's say we've got a number that is multiplying a log. Let's just say n log of a. The number can be raised to be the exponent of the log, which is a to the exponent of n. So this simply means that if we are given, in this case, n ln of a, we are going to raise the a to be the exponent of the ln. So it is going to be ln a to the exponent of n. So these are the major or the basic laws that you're supposed to understand when working with the logarithms. But now I want to extend more on this ln. We shall apply the laws, but it is important also for you to note that when you are dealing with ln, that take note of this nature. The ln of 1 over a, like this. Okay, that's ln 1 over a, like this, can be written as, remember from our laws of exponents, 1 over a means to the exponent of minus 1. So this is to the exponent of negative 1, which from these laws, an exponent, we saw that it can multiply the log. The exponent is the one that was multiplying the log before. So we can drop this exponent of a negative 1 to multiply the ln. So this is going to be a negative ln of a, like this. It is very, very important for you to note this. All right. Another thing, it is very, very important also to note this under a ln, that the ln of E is equivalent to 1. If we are dealing with ln E is equal to a 1. And also it's very, very important for you to understand that ln of 1, just like log 1 in any base, is equal to 0. So it means also the ln of 1 is equal to 0. All right, so these are the major or the importance that we need to have under our logarithms. And also don't forget this, under normal logarithms, how to change the base of a certain logarithm. That is, the logarithm of A in the base of B is equivalent to 1 over the logarithm of B in the base of A. The moment you write 1 over, you interchange these numbers. Okay, so that's A and B. Now it's B and A, which is the same as the logarithm of A over the logarithm of B. So this part is very, very important. We shall talk about it mostly when you are solving logarithmic equations. That is where you are going to have this law mostly in application. So we shall see this one later on. All right, so in this case, what I'm going to do, I'm just going to post some examples on how to apply our laws basically on this part here that we have talking with the ln, because the log we saw with this one, we talked about this in our O-level mathematics. You saw that we're dealing with log. So now I want to focus more on ln so that you understand that it's just one and the same thing. All right, so let's have our questions separately here. So the question is going to express, all right, so we're going to be expressing, or so let's just say express the following. All right, express the following. So we are having express the following as single logarithms, as a single logarithms. All right. Some of the important parts I shall be explaining as we are moving on. There's no need to rush. We've got our time together. So I shall explain a lot of things that you need to understand from past exam papers. So for now, let's have the basic part of how to simplify. Okay, let's say we are given, in this case, the ln of 3 plus the ln of 9 minus ln the square root of 3. And you're asked to simplify, that is to express as a single log or as a single ln. That's a log. With the laws that we saw before, we saw that if we are having a ln and we are adding this ln here, we can multiply the numbers. We can subtract the ln, we can divide the numbers. If a number is multiplying a ln, it can be raised to be an exponent, which means we can drop that exponent also. So now we have got a condition where we have got a square root of 3, 9, 3. So here, yes, we can have our laws of dividing and so forth, but on this type of equation, there is something familiar here about 3, 9, 3. These can be expressed to the same number. Okay, the advantage is that, guys, you see, maths, we have some advantages that we have in maths. Remember that if you are dealing with algebra, you can add terms like 2x plus 3x plus 5x. There's no need for you to factor out to say, the x is common, let me factorize x. You can just add 2 plus 3 plus 5, which is going to give you 10x. What are we adding actually here? What are we adding? We are focusing on the coefficients of the terms which are the same, in this case x. So can we write this in the same format that is maybe having in simplest form of ln 3? Because if we can have, let's just say it was 4 ln 3 plus 3 ln 3. As long these two terms are the same, there is no need for laws here. We can add just like normal 4x plus 3x. So I can add properly here 4 plus 3, which is 7 ln 3. There is no need for law. So can we write in this format? Yes, we can. 9 can be written as 3 to the power of 2. So this can be given as ln 3 plus ln 3 to the power of 2 minus the square root. Remember, from your exponents, square root means to the exponent of a half. So we can drop the exponents from this law now. Here we saw that if a number is multiplying a log, it can be raised to be an exponent, which means if it is an exponent, we can drop that exponent to multiply the log. So this here is going to give us the ln of 3. We drop our exponent. So if we are to drop this, this is going to be plus 2 ln of 3. We drop a half, it is going to be minus a half ln of 3. All right. In this condition, we can see that we have a condition now of ln 3, and so on. So here we've got the coefficient of ln 3, which is 1. So we can add these numbers, 1 plus 2 minus a half. So we are going to simplify these numbers together. So if we simplify 1 plus 2 minus a half, this is going to give us 5/2. So the answer is going to be 5/2 ln of 3. So some questions, they are direct only here and there where you have to apply the laws, but they are so direct questions. So you have to be very, very careful when simplifying those typical questions. All right, let's check another example. Let's check another example. Let's check another example here. All right, still on simplifying or expressing as a single log. Let's say we are given the ln of 2 plus the ln of 4 plus the ln square root of 2. Just like the previous question, we can see that it's just the same. So we can write these numbers into a same number of 2. The simplest number can be 2. So meaning to say 4 can be written as 2 squared. So this is going to give us, so we are going to have, in this case here, the ln of 2, all right, plus if we drop the exponent, because it's now ln 2 to the power 4, so you can drop our exponent just like previously. We saw that square root is same as to the exponent of a half, so we can drop the exponent as half ln 2. So now we have here 1, 2, and a half. So we can simplify these numbers together. So 1 plus 2 plus a half, this is going to give us 7/2 ln 2. So we are having ln 2 just like x as a common term. All right, so that is how these questions can be given, where you can express in terms of the same log. Okay, this can also be in terms of x. So do not panic even if it is in terms of x, because you might be given a consideration. Let's say we are given something like 5 ln of x plus 2 ln of x to the exponent of 3 minus 3 ln x to the exponent of 3 plus ln square root of x. Still, we can have the same thing, because here we can see that we've got x, we've got x, we've got x, we've got x. So that means we can express this in terms of x. Once we have ln x, there is no need for laws. You can add, subtract, whatever that you are given direct. All right, so let's try to have that. So how are we going to have this 5 ln x? Here we are going to drop our exponent is to the exponent of 3. So it's 3 times 2, which is 6. So that's 6 ln of x. We drop our exponent here, 3 times minus 3, that's -9 ln x. Remember that we said the square root is same as x to the exponent of a half. So we're going to drop this half. So it is going to give us plus half ln of x. So as we can see, we are given terms containing ln x here, ln x here, ln x here, ln x here. So we can affect the terms, that is 5 plus 6 minus 9 plus a half. So you add these ones on your calculator, you are going to obtain 5/2. So that's 5/2 in this case, all right? Or 5/2 ln of x. So that's a single log, or a single ln. That is a logarithm. Okay, so that is how we can apply 1 or 2 of these typical laws. Okay, the last question that I'm going to have with you is a condition where you are solving a certain simultaneous. Let me just pause this question. since we are going to work on more of these, so I'm going to pose more questions separately, just maybe one question from past exam paper, one question on each and every topic that we have done so far, so that you see how do they ask these questions. So you are going to have a lot of information as we move on. All right, I'm given this question to solve. So this, let's just say this is question 5. So in this case, we are given to solve simultaneously. All right, or solve this, okay, simultaneously. We are given ln of x. Let me just have it in another way. All right, like this. We have got the ln of x, ln of 3x minus y in this case, which is equal to the ln of 2 plus the ln of 4. So this is a nice question because it is going to help us to know the application of logarithms. Okay, so we have got two equations here that we are supposed to solve for x and y. So the question is, we have one equation with logarithms, another equation just normal variables, just a normal algebraic expression, which we are used to. So we can change the logarithm part to a normal linear or to a normal equation or normal algebraic equation that we are used to. So how can we do that? Okay, I want you to understand something here. If you are given logarithms, it is very, very important. Like I said, some of these things I'll be explaining as we move on. It's very, very important also for you to understand that if given the logarithm of a, we talked about this in our O-level mathematics, where I said if the bases are the same, let's say we are in base of 10 and you're dealing with log of a base 10 is equal to log of b in base of 10. If these two are equal, this moment that we see that the logarithm and the base are the same, therefore it means a is equal to b. These two are equal. So it is the same approach that you are going to have because you are dealing or you are working with a ln. So it means the ln of a, if the ln of a is equal to the ln of b, because the ln, it means the logarithm of a in base of e is equal to the logarithm of b in base of e. So if we understand it from this concept, therefore a is equal to, it means ln a, if it is equal to ln b, therefore a is also equal to b. So if you have got a single logarithm, the ln of x plus 1 is equal to the ln of 3. It's a single logarithm. Here we have a single logarithm. What are we going to do? We simply equate these two, x plus 1 to 3. So that means we can formulate an equation to say x plus 1 is equivalent to 3. So we can calculate the value of x or whatever that you are having in this case. So that is how we can have a single, that is how we can change a logarithmic equation to a normal equation that we are used to by equating from a single log. All right, so let's check what we have on our equation here. We are given this, which is not a single log, because if you have to check on the right-hand side, this is ln 2 plus, which means we are supposed to have a single log. On the left-hand side is fine, we've got a single log, but the right-hand side, we now go back to our application of what? The laws of logarithms. We are adding the logarithms in this case, ln of 2 plus ln of 4. We are adding. What is going to happen? We said we are going to multiply the numbers under the log, which is 2 times 4, which is ln 8. So meaning to say, this whole part is going to be ln 8. That means we are having the ln of 3x minus y like this, which is equal to ln 8, a single log from the right-hand side. So these two, they are equal. So from the concept that we saw before, that once a log is the same in base, which is same as a ln, it means a and b, they are equal. So here we are going to equate, since we are saying this ln here is equal to the ln of 8. So therefore, 3x minus y is equal to 8. That is what it means. So we have an equation here that we have formulated. So that means we can solve now these two linear equations that we are used to this equation. So we are going to solve this with another linear equation that we got from where? From the logarithms. So the logarithm part helped you to obtain a linear function, which you are going to solve. So you can have these equations separate. It's like another question now because you have formulated something else. So you can even write your equation separately. X plus y is equal to 4. Then 3x minus y is equal to 8. These are the two equations that you're going to solve. So depending with how you want to solve, is it by elimination? Is it by substitution? Whatever method that you want to use. Okay, in this case, I'm just going to make y the subject from this equation. I'm going to use substitution. Y is equal to transpose to the other side. It's going to be 4 minus x. From this equation, I'm going to transpose y to this side. So y is equal to 3x transpose 8 to this side. So it is going to be a minus 8, meaning to say y is equal to 3x minus 8. So these two, they are equal since y is equal to this and y is also equal to this. So it means I can equate these two together. 4 minus x is equal to 3x minus 8. I have formulated an equation only in x. So it can help me to solve for x by transposing whatever side that I want so that I can solve for x in this case. All right. So in this case, you can transpose this minus x to the other side. So it's going to be 3x plus x. Transpose minus 8 to the left-hand side. So it's going to be 4 plus 8. 4 plus 8, which is 12, is equivalent to 4x. Divide by 4, divide by 4, we are going to obtain the value of x in this case. All right, so our x is going to be 4 into 12, which is equivalent to 3. So to obtain the value of y, since we said these two are equal, x is, these two equations of y, they are equal. So you can substitute the value of x into any of these two equations so that we can have the corresponding value of y. So let's say I substituted into y is equal to 4 minus x. So it's going to be y is equal to 4 minus x, which is 3. So y is going to be equal to 1. Let's say I substituted into y is equal to 3x minus 8. X is equal to 3. So y is equal to 3 times 3 minus 8. So y is going to be 3 times 3, which is 9 minus 8. That means we are going to have the same value of y, or the same value of y, which is a 1. All right, so that is the value of x, which is 3, and the value of y, which is 1, which we solved from any of the given equations. So you choose which one to work from. So these are the typical questions, guys, that you're going to have. So we are going to have more questions as we are going to move on with our revisions on the logarithmic and exponential functions, like I said, from past exam papers, so that we see how do they ask these questions and how are we supposed to attempt those typical questions. But for now, that's what we had, guys, from Meson African Motives, still on A-level mathematics, till we meet again.